not here. But one of the issues we have between the fossils and the extants is, can we identify particularly leaves as, I call them bennies or benthitales, versus a cycad. So we thought, well, maybe we should look at this in some detail and find out whether there really are characters. So let's just go through that. So they coexisted, and fossil stems, in fact, you can tell them apart really readily. And one of the reasons you can do that is because the fossil stems have anatomical features. In fact, Gar mentioned one of them, the presence of girdling leaf traces, medullary bundles in the past. We have a whole suite of stem characters that we can use if we have that kind of preservation. But leaves, they all look the same to a certain extent. In fact, here's a list of the sorts of things you get with seeds. And the only other issue with stems is whether you really need to get a little bit of a section, if you don't have these other characters, to determine whether those little things in there are vegetative buds or reproductive structures. And so that sort of became an issue for us. So this kind of thing that we see here. So you might distinguish that, and you can do that with the fossils. So we're really trying to identify, of course, place fossils. So the isolated leaves, there are particular characters that have been used. Basically, this whole thing about syndactylic and haplochelic stomata, for example, which I'll show you is not perhaps the best thing. So there may be some other kinds of internal structure, if you can get to it, that would prove to be a useful feature. So we're going to look at some of those. So part of this, as I mentioned, has to do, good typo, has to do with stomates. And it ends up, it's not that simple of a question. And in fact, you really, in many cases, the mature ones may have different developmental pathways. And we know that from a lot of angiosperm and other studies. So you really can't tell from the mature structure if, what I'm trying to say is two things can look the same, but they have different pathways in terms of the pattern of cell division and vice versa. So we kind of, in a way, think that's not going to work. One of the things that's been used traditionally is also this whole deal about sinuous cells in the epidermis. Well, there's some cycads that have those things too. And it's fairly common in certain cycads generally, like parts things of Cycas and Stangeria, etc. This is the same thing, to go back to this thing about the stomates. So this just clarifies that. So, the sinuous anticlinal walls occur in at least 3 extant genera. So we're just trying to say, probably those things that occur in some of the fossils. Most of the fossils go on stem lineages to extant genera. And so maybe some of our traditional characters go away. But there are very useful characters in the group that you can use. I think that possibly people haven't been looking at in a certain sense. And some of these are, whether you have this list here of articulate or recurrent leaf, which you can all read this, but we want to take a look at some of these things. So for example, in the extants, the decurrent leaflets are things like this, where the leaflets are decurrent down the rachis, and the articulated ones will not have that. So we'll just take a look at those. And you see all this stuff in the fossils, right? So here's good examples of the articulated type in Microcycus and Zamia in particular. And we do find these articulated leaflets. What this is about is, we'll see, is about shedding your leaflets. So they're articulated instead of decurrent. And it'll come up again. So in the cycads, we've said that there are these 2 basic types. And here again is another feature that goes with it, and that's the presence of a midrib. So generally speaking, I think most of the benthitales don't have a midrib, but we might look for that to try to determine if there's some of these other characters. So you have these midribs, and in the cycads, the midribs that are there are actually homoplasias, in the sense that this is composed of a single vein in Cycas, and then when you go up to get a midrib again in Stangeria, it's composed of multiple veins that are parallel to each other. And in the Zamia, it's where they occur, they're actually formed as anastomoses of dichotomies. So it's sort of a pseudo mid-vein, right? But those are all features that one can look at, of course, and get details in the fossils. Other characters that occur in extants, but are not known for any fossils yet, but are things like on the left, macrozania. There's this peculiar feature where the leaflets join the petiole, and it's sort of a callous bump. In the extants, it's really a useful thing because when you see one of these things in the field, you'll either see these yellow structures along at the base of all the leaflets. Some of them are red. There are orange ones. There's some functional significance that no one really has any idea about. But what I think sometimes we haven't looked for these in the fossils is what I'm talking about. And then there are other peculiar features like in Zamia manicata or Zamia macrocura, where you have a petiole. Don't you love that word, petiole? But the leaflets are stalked, and they have these peculiar gland things. So this is the abaxial side of these leaves and the adaxial side. So there's some sort of glandular structure there. No one knows anything about it. I've been too lazy to section them and figure out what they're doing, except I do know they have sort of big masses of stomates. And then there are other species that have this sort of circular glandular structure. In the case of that species, it may be an ant habitat. Other characters at different levels are these things like what we call anaclinal wall pegs and perforations. And it's pretty easy to see this because these are these perforated cells. And if you look here, these cells have perforations in their walls. In the upper one, you have these pegs or thickenings of the wall that extend into the lumen in a particular pattern. And some of that's been known in fossils. For example, in Kurtziana, you can find these perforations. So we have some characters that we might be able to work back and forth with those. And there are many species of cycads that actually, in fossil cycads, that have these characters that the extants do. Epidermal cell patterns work, and this was actually what started this whole thing, was the thing named for Ruth. Because I can't see that here, but Peter does. But there's these weird, I don't know how to say it, this oblique angle of epidermal cells that actually was in this fossil. And there's another fossil that has that, apparently from Australia, that was actually described by Cookson. And so we have another epidermal feature that we begin to look at in these. Another peculiar thing about cycads is, if you look in the upper right, most of the cycads that have these big trunks often are not deciduous. But many others, like zamias, this one's starting to be deciduous, where when they're deciduous in terms of losing leaflets. So they upsize their leaflets. So what you should find is isolated petioles with leaflets. So you might be able to, utilize that kind of data. And then this kind of thing over here with persistent leaf bases would tell you something on trunks. We like them. The other thing that goes on, I think, is when you're looking at gross morphology, the point of this is just that if you try to use these gross morphological shapes and stuff, you can see that you could align many fossil leaflets to extant genera just based on these shapes and general outlines. And if you look at this, you can see there's more than one diune on the left-hand side versus matches on the right-hand side. So part of the point here is, rather than the gross morphological features, it might be well advised to focus in onto very specific internal features and anatomical features of cell patterns on these leaves. And this is just another example where, what do? Here's a diune over here, and there are other things over here that look very much like diunes. So if you're trying to code these in a matrix, it really generates a huge problem. And then you get these things where some things, interestingly enough, when people got into particular features, here's something that went from being a Benny to a cycad. So part of my point is using combinations of characters may elucidate things and allow us to avoid make errors. So basically, the point here is that there's a lot of features in the extants that I think probably have not been exploited in looking at the fossils. And with some of our new tools and methods, we can get a little more information, particularly on the leaves, because I'm really bummed out about the whole thing. How did these pinnately derived leaves come? How were they divided up? And so people have lots of ideas. Now, I have one other thing that's a question for you guys. I just stumbled on this because this guy sent it to me, and then I'd forgotten about it, and I found it like 2 days ago or something before I came. How many people know about Michael Wachtler? He's in the type tribe. Yeah. This guy is publishing like a fiend. Like 2 or 3 of these monographic things every year. And I'm just pointing it out to people because he's got all these papers on the origins of the angiosperms. And apparently, this is the place where the best fossils in the world are, if you want leaves and angiosperms. So that's the story for today. And I think part of that story is dealing with trying to understand those things that can be homoplasias and in these plants by convergence because of habitat similarities and to separate them out. So with that, we'll thank all of our supporters.